Good morning, good afternoon, and welcome to Cafe Dev. This month in July, I want to teach you, if you're a developer, how to create IoT solution from scratch. If you don't have any device, any IoT device, if you don't have a Raspberry Pi, that's not an issue. You can totally follow along these modules. So join me and a special guest in this first video about an introduction to IoT Hub and IoT Edge. So in today's video, we will introduce the basic of any IoT solutions. For an IoT solution, an Internet of Things solution, you definitely need some devices, but we will see that as a developer, you can start your project without having any device, and you need some cloud, some ways to actually interact with these devices and get all the data they can send and process them and get them into your backend solutions. So for this module, I'm joined by a special guest. Welcome, Benjamin.
Bonjour. Hi.
Hello.
How's it going?
Hi. Great. And you?
Good. Pretty excited to be. I mean, this is going to be all about IoT this month, right? Pretty
Yeah.
excited to kick this off with with this great live stream.
So we will start this live stream with basically a few housekeeping items. If you're following us on YouTube, you can ask your question directly within the YouTube chat. It should be at the bottom of the video or at the right of the video. And if you're following on Twitter, you can also ask your question directly as a reply to the Twitter video. Also, this video is not just a course. We will actually, in the second part of the video, do some practical exercise, and you can follow along with us right now, or if you're watching the replay, you can do it later on directly on Microsoft Learn. Microsoft Learn is a free platform for actually trying out and learning a lot of different things about Microsoft technologies. And you can go on aka.ms/JulyOT/learn to get a collection of modules for all this month's video series. So let's check what I have on this list actually, and it's here, and let's get some music behind the scenes too. So I've created this collection where you can see all the modules, and for today I have only 4 ones. So the first one is a global introduction to Azure IoT. As you can see, it took a little bit of time to go through all these modules, but it gives you a great overview and especially a business overview of what is IoT and what it could be useful for your company. So we will not follow this module for now, but it's an interesting resource you may want to check out later on. And for today, we will actually do these 3 modules together: an introduction to what is Azure IoT, what is Azure IoT Edge, and in the second part of the video, we will actually write some code to remotely monitor and control devices with Azure IoT Hub. So let's get started with the first module, introduction to Azure IoT. Be sure, if you're following along with us on Microsoft Learn, to actually sign in so you can keep your progress and so you can continue when you have time if you didn't finish any module with us today. So let's start with Azure IoT. So Benjamin, you're part of the Azure IoT engineering team. And obviously, when we talk about IoT, we talk about devices. But what kind of devices we are really talking about when we talk about IoT?
Well, it's all about connecting the physical world to the good old world of IT, right? So the physical devices can be many things, but in in a nutshell, you're thinking sensors on one hand. So you want to monitor, I don't know, like building, like creating a smart building solution. So you will have tons of sensors for all the thermostats and like the humidity sensors and so on. And potentially you'll get in the realm of actuators. You want like from the cloud or from your like IT infrastructure, you want to influence the physical world by turning lights on and off, powering and turning on a valve in maybe a water tank, that kind of stuff. So those are like the very basic like physical things that you will be manipulating, and they become quote unquote IoT devices when you start connecting them to the internet, right? So in order to connect them, you will need some kind of either like a super tiny microcontroller that like allows you to do maybe Bluetooth, maybe like low power connectivity using 5G, maybe, right? Or maybe you can afford, or you actually want like a more beefy, a more capable connectivity solution, and you will have what we call more like a gateway, an edge gateway that will have actually the ability to aggregate and to concentrate dozens of sensors, like literally at the edge, hence the name, at the edge of your whatever is your physical infrastructure. So your edge might be your factory floor, might be your house, might be a car. Like all the sensors that are in the car, you aggregate them on your edge gateway. So yeah, I think that's pretty much it, and pretty nice drawing skills there.
Yeah,
I
thank
just
you.
can't do that. I just can't. Like for me, that would have been ugly if I allowed
I'm
that.
trying to do some not so ugly drawings, but one of the interesting things you said is actually the range of types of IoT devices can be very wide. Like you talk about a small temperature sensor, but also in a way we can see a car as an IoT device, right?
Mm-hmm. Yeah, and there's a lot of like there's a term. I mean, I'm sure that applies to more than just IoT, but in IoT you often have like a the brownfield solution where the physical things, the sensors, the actuators, are stuff that's already like there in the field, and that's been there potentially for decades, and you sort of want to retrofit and IoTize them by connecting them to the internet. And that's usually where a gateway makes a lot of sense. And for greenfield solutions, for like the new solutions that people are imagining with like new use cases and so on, you have a lot more flexibility. But that like you said, there's really tons of different scenarios. You have different constraints depending on the use case, depending on like just like the kind of solution you build. Like if you just have 10 IoT solutions all around the world, you might not care so much about how much your microcontroller is going to cost you, how much having the connection in place is going to cost you. If you're thinking about putting a sensor in each and every shoe or safety helmet of your construction workers, then like it's a completely different story, right? In terms of battery consumption, in terms of just cost, right? Saving a few cents is going to make a huge difference. So, yeah.
Sure. So the first component of IoT solutions are obviously IoT devices. We talk a little bit about communications. Can you maybe give you more information about the kind of different connectivity we have? Because I mean, Bluetooth and Wi-Fi are pretty common for developers or normal people because we have all phones with Bluetooth and Wi-Fi, but I don't imagine putting a phone to get the temperature somewhere with no battery, no power. So there is also a way to connect how you can decide the type of communication you can have.
Well, some people might use their phone, but you're right. Like oftentimes you're thinking about like devices and sensors and so on that are in location that might be super remote. So like just in general, in terms of like the communication, it will have to cope with the fact that the connection might not be super reliable. Because I mean, you're like again in a super remote location, so you're looking at protocols like maybe MQTT, which is like particularly like designed for IoT constraints. It's super efficient in terms of bandwidth and so on. And something like MQTT, you might use it over like actual radio protocols that are more geared towards IoT, like cellular. You like the actual modem, the actual communication device might not be a phone, but under the hood it might still use cellular. So you might have a device, a smart helmet, smart shoe, whatever, that's going to use cellular. You might look at protocols like LoRaWAN, like what's called the LP1, so low power wide area network protocols. Yeah, what else? I'm sure there's more that could come to mind, but like there's lots of variety there, and lots of you might actually say fragmentation, but that's why there's also different topologies in terms of how you might architect, design, and deploy your IoT solutions. Exactly like we're going to see today. Are you not going to use a gateway, an edge gateway in your solution to help sort of federate your different sensors that might be using different protocols? There's also all those protocols that are part of the brownfield picture, like in the industrial world, Modbus, Profinet, EtherCAT, whatever, like protocols that are dedicated to smart building, to cars, etc., etc. How do you route them to the internet? Well, probably you need a gateway, right?
Yeah. And obviously, when you have IoT devices, when you found a way to connect them to something, usually you have some backend services that will actually process all this telemetry data and display information to users or take actions, as you said, with actuators. So obviously, at some point in time, we will need to have something that communicates to our backend services.
Right. But then the good news, I think, there is that it's almost business and IT as usual. Almost. I mean, once you've done the hard work and the hard job of getting your devices connected to the internet, well, you have data, like time series data, that you can just put into time series databases and route into your ERP. Maybe if you want to like tap into your existing ERP system, I guess it's almost idea as usual, since you still want to be careful about all those devices you have in the field that are pretty much like headless and have no UI whatsoever and are just like super remote location. How do you manage them, like from a what software they are running point of view? Are they secure? Like what happens if one of them gets compromised? So there might be some some things that are not like regular IT in terms of doing device management, essentially what's called device management.
Yeah, sure, and that's definitely something that is specified in the Azure, in the Microsoft Learn modules. Actually, I don't remember where, but one of the issue people have when they're trying to actually deploy an IoT solution. We have a lot of people who have an actual idea or but make a proof of concept, but when they try to scale this proof of concept, they end up having some issues. One of them is security. Oops, it's too big. Security is a big topic. Management of devices, you say it. Management of devices is also a big topic around managing all these devices, keeping them up to date, and deploying them, that kind of things. And it's where actual solution like Azure IoT Hub can come and have some solutions. So next step in this Microsoft Learn module about IoT Hub is actually discovering, because we have a lot of different products around IoT, right? And the idea is to of this page is to basically go through the most useful products we have if you want to create your IoT solution. So the first one, it's most of the time I would say is the obvious one, is Azure IoT Hub. Would you like to explain us what is Azure IoT Hub in a minute?
Sorry. Yes, absolutely. But in a nutshell, it's the best way to summarize it is it's the cloud gateway. Like we've mentioned that sometimes you might have a gateway at the edge, but in your nice drawing, essentially, you have on one side the devices that are somehow trying to communicate to the internet. You have the edge gateways that are trying to communicate to the internet. What it is that they are trying to reach or connecting to. This is what we call IoT Hub, what others might call a broker, but it's essentially just a gateway, right? It's what's taking care of making sure that the devices that are connecting to it are authenticated and authentified, and that they are actually allowed to communicate, making sure that their data gets routed to the proper consumers. Again, might be an ERP, might be a time series database, and the gateway essentially provides all the APIs that at the end of the day an application developer might need to effectively interact with the devices, either again consuming the data or performing device management operations, sending commands maybe to the actuators, and doing so without having to worry too much about security, scalability. You might have like hundreds and thousands of devices. So how do you, like, hey, I want to turn the light bulb on all my devices. How do you make sure you don't kill your network while doing so, etc., etc.? That's what the Cloud Gateway / IoT Hub is all about.
Sure. So basically, it's IoT Hub is a way to like manage all the devices and having a database of all the devices connected to our system, and routing the messages from the devices itself or the edge gateways to your actual backend application. And while doing so, IoT Hub is abstracting all the differences between the way your devices are actually communicating with the cloud or the range of devices you're trying to reach. So as a developer, you have a unified API to actually manage all these different devices, whatever they are, wherever they are, or whatever they are, or the way they communicate with the cloud. We have also different product that may come across when you're trying to design an IoT solutions. The next one, I will just spend a few seconds on it because we will have an entire module, an entire video later this month about it, is Azure Time Series Insight. So as you said, Benjamin, sometimes we want to aggregate data from a specific sensor that is chronological data, and time series insight are a special kind of databases that allows you to store, query, and visualize this kind of data. Then we have Azure Sphere. So Azure Sphere is actually an end-to-end solution. It's a set of products with hardware, OS, and a service that allows you to secure microcontrollers out in the wild. We not spend so much time on it, but it's definitely an interesting product if you have some huge security requirements in your IoT product. Azure IoT Edge, I will also skip it for the moment because we will have a few minutes in a moment to talk a little bit more about it. Benjamin, you mentioned that provisioning all the devices, ensuring that the devices you're communicating with is actually your own device, etc. And I mentioned that some projects have issues when we try to go from a POC to an actual real-world deployment. Azure IoT Hub is a feature. Azure IoT Hub Device Provisioning Service is actually a feature that allows you to provision and deprovision a huge number of devices in a scalable manner. So it's not something you will use as a developer when you're creating your POC, but if you're trying to actually deploy your real-world project, it may come useful at that time. But I don't know if you want to say a word about Azure Digital Twins, or if you want.
Yeah, well, I mean, just in general, the term digital twins, for those who are not familiar, is just figuring out a way to have in your in the IT side of things, have a digital representation of what you may find in the real world, right? And making sure that you have all the ontologies and all the ways to model what might be the relationships and the dependency that you would observe in real life between, say, a building and all the rooms in that particular building and all the thermostats that there might be in this particular building. And that's only for a smart building use case, right? And with Azure Digital Twins, you can actually model all this this graph, if you will, and then that essentially enables you to once you have real world devices that are feeding data into your system, you can put that data into context, right, and make smarter decisions that way, because you realize that yeah, in a particular room, the occupancy sensors tell you that the room might not be that occupied on a particular day, so it might drive business decisions in the way you will maybe like reassign, reschedule meetings or whatnot. But that, yeah, that's essentially yeah, bridging physical world and digital world, and providing all the semantics. We actually have a language that allows people to model essentially what their digital twins are. It's called DTDL, Digital Twin Description Language. And yeah, check it out. We actually refreshed the it's currently in it's a service that's in preview, but we did some huge improvements lately. So just go and check it out. Yeah.
Great. And we also have a bunch of other projects that are more or less related to IoT solutions. One of them is Azure Maps, which is a collection of geospatial services that allows you to either doing things on geospatial data or actually displaying some maps. So depending on what you're doing with your IoT devices, for example, if you're tracking trucks or that kind of things, this service could be useful. And obviously we have a ton of other different services across Azure that are most of the time used in conjunction with IoT architecture, but it's going a bit far out of our topics. But you have a list in the Microsoft Cloud module of some services like Azure Machine Learning, Azure Stream Analytics, Azure Data Lake, Cosmos DB, that could be useful depending on what you're doing with your data from the IoT solutions. So we will not go through all this module. As the next step, and I encourage you to check out after the stream, is one, to use Azure IoT and a little knowledge check also if you want to check what you just learned around IoT. So I encourage you to go again on aka.ms/JulyOT/learn to finish this module by yourself. So if we'll go to the next module, which is an introduction to Azure IoT Edge. But just thinking about what we just saw is basically, let's say I having as a type of devices, I have a video camera, like a CCTV. If I want to do some analysis, well, it seems not very efficient to send all these video feed to the cloud to be processed on the cloud. Benjamin, you told an example about digital twins when we want to understand if a room is occupied or not. Maybe we can deduct this from a video feed with some AI. But yeah, it doesn't make any sense to send all this data gigabytes of video data to the cloud to decide in the cloud if something wrong is happening. You thought about a factory. If you're in a frozen goods factory, you don't want to, if one of the refrigerators goes down, you don't want to send all the data to the cloud to decide that something wrong is happening and sending back the information to one of the factory workers. So basically, Azure IoT Edge is is a set of different services based on top of Azure IoT Hub that can help you do that kind of things. So basically, Azure IoT Edge allows you to deploy to some advanced IoT devices. It could be IoT gateways, or it could be quite powerful IoT devices. And you can actually deploy your own workloads as a containers onto these devices. You can even use just a Raspberry Pi to do it. It's sufficient to host a couple of containers. So you can actually process this data in near real time, very local to where the change happened or where the sensor is getting this data. And Azure IoT Edge will allow you to actually manage all these things. So if you're deploying hundreds of gateways, Azure IoT Edge will ensure that all these gateways have the proper containers running, and all the communication between the sensor and the containers is done for you. Benjamin, do you want to add something to this short introduction to IoT Edge?
I think you actually nailed it.
Great. So I encourage you to check out how IoT Edge works, but basically Azure IoT Edge, it's quite easy to grasp actually when you understood the basic of Azure IoT Hub, and if you already know what is a Docker container and how to create it. Basically the only thing you have to do is to deploy an IoT Edge runtime on a device that supports containers, and then you can Dockerize your components and create a definition of them. So you will have an IoT Edge module definition, and then you can from the interface or from the code deploy IoT Edge modules to specific or to all your IoT Edge enabled devices, and then you have a cloud interface to manage all of this. And one of the cool things also of IoT Edge is you can deploy your own workloads, but you can also deploy Azure functions. It's in public preview, I think, or private preview. No, public preview. You can deploy SQL Edge, which is a version of SQL Server made for ARM architectures, and you can deploy it on the edge. And also you can deploy a subset of Azure Stream Analytics workloads. So you can actually do a pretty interesting things with IoT Edge. Benjamin, what do you think about we write actual code for IoT and digging into how to actually create and code something?
Depends. Are you going to write C#? Because I'm more like a Java and JavaScript guy myself. But sure, let's do it.
Yeah, so I would write C# today because I'm more a C# bug. But actually, within this Microsoft Learn module, we have samples for Node.js. So I can show you the code in Node.js. And if you're neither a C# nor a Node.js developer, that's totally fine. Azure IoT Hub supports a wide range of languages, and if it doesn't fit your language, if we don't provide the appropriate SDK for your own language, you can access all these features of Azure IoT Hub through a REST API or some open source protocol like MQTT, like mentioned Benjamin. So what we will do in this module is first we will create an Azure IoT Hub using the IoT Hub portal. So we will create your own cloud gateway instance within Azure, and you have full control over it, and it's totally managed, so you don't have any server to deploy or to configure. Everything is managed for you. Then we told you before that within IoT Hub you have kind of a device registry. So we list all the devices that communicate with your IoT Hub. So we'll go ahead and create one device identity, again using the Azure IoT Hub portal, but you have other ways to do it. And then we will create two different apps, two very simple apps. One of them will simulate an actual IoT device, which is cool because even if you're a developer and you don't have any device, any Arduino, Raspberry Pi whatsoever, you can actually write some code and demo your concept without having a real device. And then we will write a second app that will actually listen to all the incoming telemetry we get from this simulated device. This module will go ahead and even show you how to control remotely devices. We may not have the time during today's stream to show you that, but again, all the code is here, all the tutorial is on Microsoft Learn, so you can follow along after our stream if you want to see how we actually control devices with Azure IoT Hub. So let's get started. What we want to do within this module, and you will see this theme across a lot of different Azure IoT modules, is we're thinking like we were a cheese factory and we want to track different things related to cheese and to cheese transportation. So I would go, sorry. Yeah, I already completed the module, so because I'm signed in within Microsoft Learn keeps sending me to the last page, but we want actually to go over again to the first unit. So one of the good things of Microsoft Learn, if you don't know Microsoft Learn, is we, as you can see, actually there is a sandbox within Microsoft Learn, and I only have 30 minutes, so things will be interesting. But actually you don't have to have any Azure subscription, and even if you have an Azure subscription, you can use directly the sandbox provided by Microsoft Learn to access free Azure resources while you're learning. And when you've done with this module, the sandbox will be decommissioned and you don't have anything to think about or to pay or whatsoever. So it's a great way to get started with Azure. So the first thing I will do is I will create an Azure IoT Hub. So I will right click here to go on the Azure portal, and I will just skip the authentication part so you don't see my password. And here I am in the Azure portal. Oh, it's in French. Let me change it to English. Yep. Apply. So to create a new IoT Hub within the portal, you just have to click on create a resource, search IoT Hub, click on it and click create. And then you will be required to do to input a few different things, and everything is listed again on the Microsoft Learn page. First is a subscription, is where you get billed. So because I'm running into the Microsoft Learn sandbox, I can select the concierge subscription and it's free for me. Resource group, it's a way to group a set of Azure services. And again, the Microsoft Learn sandbox creates one resource group for me. So I have nothing to do here except selecting the only one resource group I have here. And then I will select a region. It's quite important, the region settings, because A, you cannot change it afterwards, and B, you want to be sure to select a region that is closest to you to limit delays in communication, etc. So as I'm based in France, I will go over and select France Central. Then I have to input a name. You should be aware, and it's explained in the documentation, that the IoT Hub name should be actually unique across all the Azure customers. So if I choose Cheesecake Hub, as you can see, this IoT Hub name is not available because somebody else has used it in the past. So I will need to go over and to personalize it. And anybody can actually discover this URL. So if you have a top secret project name, don't put it in there. Next set of questions is about networking. For this demo, I will just select a public endpoint, which means that any device that can access internet can actually communicate with my IoT Hub if they have the right credentials. But if you're in a more secure environment or you have network constraint, you can limit this to private endpoint and private networks. Next step is about size and scale. So there is a few things to know there. You have actually 3 different tiers. The free one, the basic one, and the standard one. Free and standard have the same features. So if you want to use IoT Hub for development purpose, for example, you can choose a free tier. The main differences between basic and standard, and Benjamin, if you have anything to correct me, do not hesitate. But basic tier is mainly for devices that are only sending information to the cloud. So it's what we call device to cloud communication, D2C. So you cannot send orders, for example, from cloud to devices, C2D. If you're using the basic tier, you need to go and to use the standard tier to be able to send commands. And then you have, as you can see, for each tier, 3 levels, S1, S2, S3, which is basically the number of messages you can handle per day. And then you have the number of units. So if you want to scale to a huge number of devices, you can actually do it as well. So I will go just on the standard tier, and with just 1 unit, it will be enough for me. Tags is something quite common in the Azure world. Is just a way to add a key value items, mainly for management purpose on any device. I will not do anything there, and I will go ahead and create my actual IoT Hub. Do not hesitate to ask a question within the chat window. I already saw that Benjamin has answered few of the questions on YouTube. Is there any question you want to read out loud? Oh no.
There were some questions earlier around what exactly is digital twins? How does it relate to existing solutions that might enable to simulate IoT data? Yeah, I think I tried to answer, but I think I answered along the lines of really where digital twins can start being interesting is when you really think about like it being the bridge between physical things and other entities that live in your global graph of global knowledge graph, I would say.
Mm-hmm.
And it sort of automatically, due to all the relationship that you've modeled, it allows you to query and to extract insights from stuff that's in between the reality of physical things and thermostats and whatnot, and other stuff that might live out of your SAP environment or whatever, right? Yeah. Yeah, good point regarding if folks have questions, please use the chat in YouTube, and I will make also double check that there's no questions on Twitter either for those who watch the stream on Twitter.
Yeah, thank you. So our IoT Hub has been created by Azure, so we can go ahead and go on the IoT Hub. It's still in creating phase. But you can do a bunch of different things here. And one of the first things we want to do, as I said, is to create a device identity. So we have actually a password for this device, a connection string for this device. To do so, you can go on IoT devices on the left side menu and just click new device. You need to get a device ID. So I will choose here Cheesecake ID, and as you can see, there is a different type of authentication between the device itself and Azure IoT Hub. For sake of simplicity, we will choose a symmetric key here, but if you have more advanced security requirements, you can use a certificate to do it. So I will let I will choose symmetric key, and I will let Azure actually generate some keys for me and activate this device so she can this device can communicate with IoT Hub. I click on save, and it's done, and I can see my device here in the list of all the devices I have in this IoT Hub. Quick information. I told you about Azure IoT Hub device provisioning service before. Actually, this DPS service allows you to automate all these things. So as you can see, it's no big deal to create for a couple of devices, but if you have 100,000 of devices, you don't want to have an operator that go logged into the portal and click new on all the devices and input all the device IDs, etc. You want to automate this thing. That's why we have Azure IoT DPS service. And that's almost anything I need to do to actually create my device. And when I click on this specific device, I can get all the keys and connection strings, and these are the information I will need to put into my device itself so if this device can communicate with Azure IoT. I need to do just another thing for communication purpose, which is get the information to actually listen to events that are sent to Azure IoT Hub. So the idea here of these 3 lines of code is to actually get, and it seems that we have a lot of people using Microsoft Launch today, which is great news. But I have another way to access it. No worries. So yeah, the idea of this line of code is to actually get all the endpoints so my backend application can listen to events that are sent from IoT devices to IoT Hub. So I will run this later on. And I think that's it. I think we can go to the next module, which is actually see some code, write some code to send and receive telemetry. So if you're follow along, as I said before, you can follow this tutorial with either JavaScript and Node.js or C#, and you can do both either in Visual Studio Code or Visual Studio, or maybe another IDE if you want. Benjamin, do you know, without looking to the documentation, all the SDKs we have for devices and servers, like all the languages we support?
Yeah, so the list you have here is a good start. There's you should add C. There is Java as well, Python, and like, yeah, usually both, like from either a device point of view. I have a device, I need to connect it to the cloud. I may want to use Java, like if my device is big enough, but more likely if the device is constrained, it's going to be C or Python. And then, yeah, maybe Java or C# or JavaScript / Node. And same if I'm building more like an application, mobile application, a web application, I will use like the very same languages or like different languages, but those are the same that will be supported there for interacting with more like what we call the service APIs.
Yeah, and that's actually a good point. Let me add something here, because you actually have for this part of your IoT solution a device SDK. It's an S. Yep. And you have here a service SDK. That's 2 different services. One of them is to actually communicate as a device, and the other one is to be included in your backend application, so your application can communicate with IoT Hub. And you also need to be aware that there is 2 different connection strings. So if I go again on the Azure portal, I am here on one specific device. So this connection string is actually the connection string for this side of things. And if I want to have the service connection string, I need to get there in shared access policies. there is already some existing shared access policies, and usually for samples, I grab the root shared access policy, the IoT Hub owner, and this connection string is actually to be used on the service SDK side of things. It's time is running, so let's go and get the app, and I will choose C#. So actually, for you can follow along the exercise and copy paste code if you want, but what you can also do is to simply clone this GitHub repository where you have the device code and the hub code. So the hub code is actually the backend code, the one using the service SDK. And in both directories, you have the C# sample and also the Node.js sample. Okay, so I've already done this on this computer, and so I have here the device code and the hub code. So maybe what we can do is actually see a few interesting items, code items, and again, you can spend more time digging into your code by yourself. But one of the things we need, and it's here, is a device connection string. So because my sandbox is now out, I will need to recreate the Azure portal. I will do this on the side, but it's if it's still working from the cache. Yeah, it's not working from the cache, but it's actually I already showed you what is this connection string. I will go on the side to reboot the things. So we need to input this, and everything is already written for you. One of the things I wanted to show you is this send device to cloud messages async. So it's actually a code method to send the telemetry to the actual IoT app. So there is some code to input faked telemetry. And actually what we need to do is, and this code especially, and that code is actually the code that will interact with the Azure IoT Hub SDK. And as you will see, it's at the same time quite easy and also quite powerful. It's quite easy because one of the things you can simply do is send a JSON message to IoT Hub. So here I am creating a new object with only two fields, temperature and humidity. I'm converting this .NET object into a JSON string, and actually you need to send a specific object to IoT Hub. You cannot just send a string, you need to send a message. And why you do this? Because one of the cool things of IoT Hub is you can actually attach properties to your message. So here, for example, we are sending two custom properties. One of them is the sensor ID, and the other one is there any alert regarding the fan? And why it's interesting, because IoT Hub can actually use data from this property to route messages to the appropriate application. So let's say you have two backend applications. One of them is just a reporting application, and the other one is to actually send alerts to employees on site. And you can simply send only the messages with an actual alert to the second backend application just by configuring routing within Azure IoT Hub that will read this property. So that's something quite cool. And then the only thing you need to do is to actually send the telemetry message here. Do you have anything else to add, Benjamin, about the device side of things?
Nope. I mean, maybe just like you mentioned before, so we have all those SDKs for like many different languages. If you want to use your own language of choice, and or don't feel like you want to use an SDK for just like getting started and simulating the data, we have all the documentation required to just like understand how you would use something like MQTT to basically craft the very same messages that we've just crafted here through the SDKs using whatever floats your boat, and then get the data up into the cloud to move on to the next step, which is actually using the data.
Yeah. So I'm still creating the Azure IoT Hub from the side, so I will just get there so I can impute the connection string later on, and then we'll go to the second application, which is a backend application that is actually receiving the data from the IoT Hub. So I need to do so this application actually can do different things, and that's why you can spot different library used. The first one is Azure Event Hubs. So Event Hubs is basically a message bus. So all the messages sent to IoT Hub can be consumed as an event bus. So that's one part of the application. But as we saw in the beginning, in the introduction, the name of the third module is actually remotely monitor and control devices. And for controlling devices, we will need another library, the Microsoft Azure Devices library, that actually allows you to query the devices and to send messages and event methods to the device itself. So one of the things we can do now is I'm doing things on the sides, is looking at all the configuration we need to input within this program to actually make it work. So we need a bit more information, but on the device side, the first thing we need to do is the service connection string. So I already showed you that connection string before. That way we can use the Azure Devices SDKs and classes to interact with the devices itself. And then we will need a bunch of different informations for actually receiving the messages from the Event Hub. We will need an endpoint, we will need a path, and we will need a SAS key and authentication key. So I will get all of them in a few minutes when my sandbox is back to life, and it's almost there. So while my sandbox is still loading up, let's see a few interesting methods. And we will start by this one, receive messages from device async, where we will create an Event Hub receiver. So it's basically a component that will actually allows us to receive messages from the Event Hub. So this service, to give you a bit more perspective, this service, what we will do, the pseudocode is actually while your program is still running. So obviously you will want to replace true by something else, but while you're still running your listener service, then you will await from receiving a batch of messages from the Event Hub, and you will have a timeout. So here we will time out every 100 milliseconds. So every 100 milliseconds, this method will return, and then we will check if we have received either no events or some events. If we didn't receive any events, then we loop again and we wait another 100 milliseconds to get some messages. And the fact is, Event Hubs is created to process millions of messages per second, so very high volume number of messages. So what it does when you receive messages is the Event Hub SDK has the ability to actually batch read messages. So when this method returns, we can actually get several messages from different devices. So we need to loop through all these events, and then we get an event data class that actually gets the content of the messages and even the properties, if we have some properties, as we said on the device SDK side of things. So in a nutshell, it's a way you can actually process all the incoming messages. I have a few other things to say, but Benjamin, why I'm configuring again my IoT devices? Do you have another things to say about consuming IoT messages?
One thing that's worth maybe calling out is when you're still sort of prototyping and building the solution, there's a bunch of tools that can help you. Like earlier, Christopher was playing with the command line. But there's also a great set of extensions for and plugins for VS
Oh
Code.
yeah.
So just check out the IoT workbench in VS Code, install that, and it'll provide you with a nice UI essentially for figuring out which devices are connected and which are not, and subscribing to their data stream right from the IDE, without necessarily having to worry or think too much about all the connection strings and so on that you might require behind the scenes. So check it out.
I will try to actually connect to. Yeah, it's working. So this is the Azure IoT Hub extension Benjamin just mentioned, and as you can see, I have my Cheesecake Hub here, and I have my Cheesecake ID, which is my simulator. So actually, you can see all your devices, and you can do cool things like sending messages as it was sent by the device itself, or monitoring, start receiving messages. So even if you don't write this hub backend code, you can actually see all the messages sent from one device just within Visual Studio Code. So that could be cool during your implementation. So I'm getting the last set of information needed to actually run the program and see if everything is working. So I have here the event hub endpoint. Then I need a path, which is basically the name of my IoT hub here. And I also have a key. So this is absolutely not secure. I'm showing you my real key, but I will delete it just after the stream. And we can hope that everything is working and try it out. So here I am in my device folder, and I will just run my program up .NET run, and if everything is working, it should tell me that it sent some data. So this program will actually send a new data every 2 seconds, and you can see the payload of the message that has been sent. And now we will go over the backend application, and I will also .NET run, and it should show me all the messages sent. Yeah, so actually we got all the telemetry, and if you can spot it, 6881, and here it should be the first value. Oh no, we lost some value, 81 at one. So I'm receiving the messages almost in real time, and I then can process them. And what you can see in red is actual, it's actually displayed from the properties. So your when you send a message, I show you, let me show you code actually. When you send a message, you send a payload in it. Here is a JSON payload, and then I send some properties, and you can actually, from the hub, from your backend application, read the payload, but also read all the properties. So if you like this, I really encourage you to check out the other steps of the modules, and especially the step to invoke a direct method, which is a cool thing. You can actually ask the IoT Hub to execute a code method onto the device. We use this, for example, for rebooting the device, or as Benjamin said, activating an actuator or changing something from the backend. And you also have in this module some code to manage the device twin. Device twin is a way to have a status of the device, and we use it for a lot of different things, including updating the firmware on IoT devices remotely. Benjamin, I don't know if you want to say a final word, because before we close this first JulyOT stream.
No, thanks for having me. For folks who got intrigued or interested in the stuff, go ahead, check out the other the great content and other learning paths on machine learning, and go get yourself an actual IoT device. Right, we have the Azure IoT sort of official dev kit. It's called the MX chip. You can buy this for like a couple dozens euros or dollars, and there's like virtually all the devices out there that are marketed as IoT. You can run them and connect them to Azure IoT. So yeah.
Cool. Thanks for being my co-host today, Benjamin. So it was the first of a series of video. We will still have 4 other videos. The next stream will not be on Friday, as it has been announced earlier, but we change the schedule to Thursday, 5 p.m. Paris European time, and 8 a.m. Seattle Pacific time, so we can have more viewers joining us for the rest of the video. So the next stream will be next Thursday, and we will talk about Azure IoT Central. And Azure IoT Central is a tool that allows you to craft Azure IoT solutions without having to write any code, and even maybe without having to create your own device, because we can use a broad range of devices available. Please check all the links within the video description. I will update them in a minute. Do not forget to subscribe to Cafe Dev so you can receive a notification when the next stream is coming, and follow us, Benjamin and me, on Twitter. Thanks for watching, and see you very soon. Goodbye, Benjamin.
Bye. Take care, everyone.